Okay, a very good evening to all of you. Um, myself, Subin Koshy, I'm a PhD scholar in electrical department, guided by Dr. Sunudha R. And I'm currently working on wide area monitoring of power system, and my specific field is dynamic state estimation. And I have to adjust my PPT according to each day's session because to avoid any repetition and all. So any FDP is like actually a jigsaw puzzle. So we have to collect all these pieces from the jigsaw puzzle and we have to join the puzzle so that we can get a complete picture of what the new research areas are regarding that topic and all. So this particular FDP has offered many facilities like YouTube recordings and also we can listen to the lectures and all afterwards also. And there is a very good facility of emailing the faculty so that we can ask some relevant doubts to them. So once again, I thank my guide, Dr. Sunita R, and coordinator, Dr. Deepak sir and Dr. Gobama sir for giving an opportunity to present in such a reputed platform set up by the AICTE ATAL Academy. So apart from the doubts, if anyone is working in this field or related to this presentation, they can contact me on my email, which I'll be providing in the end. So like if they're working on the specific area, then we can think about a deeper discussion or a collaboration in the research. Okay, this is my overview for the today's session. So I'll be just giving a brief overview of the smart grid, then I'll quickly move on to the PMU and PDC, then starting with the big data properties. Actually, the big data properties have been discussed by Ms. Padmasri Krishnamurthy ma'am just before some time. So I'll be briefly going over to the properties and then I'll be going over to the challenges and some big data framework as well as discuss some cyber attacks on the power system. So this is the smart grid era. Okay, so what is smart grid and what is big data and how smartness is coming into the grid? That is what we have to discuss in this current era of smart grid. So grid is nothing but a network of generating, transmission and distribution stations. So why we need smartness into the grid is that when we go into the conventional grid, it has a lot of transmission losses. So the power has to travel miles apart to reach a customer from its generating station to the customer or the consumer. So it has a lot of I2R losses in between, which the utility has to pay for that losses. The customer will not pay for that I2R losses. So to introduce the generation there itself is a solution which reduces the transmission loss. That is why we are having many distribution generation sources. Even some of us are having some solar or wind power generation sources in our homes itself. So the generations may not be available at exactly one particular node and they will be locally generated power which can travel less amount of distance compared to the conventional grid to reach the consumer. So apart from that, people can also generate and earn income as well as from the generating sources. So our first point is that smart grid uses, it's a network that uses IT to deliver electricity efficiently. That is the efficient delivering of electricity. The second point is actually reliability. So in order to have reliable power, we have to upgrade the level of power system protection. So that the power system protection equipment, they can take a smart decision. Like a feeder which has to be addressed due to a particular fault and all, those particular feeder has to be opened so that it will island the remaining part of the network from the faulty feeder. And the third point is security. And this means that the information within the grid must remain secure, and it must not be interfered by any outsider. So thus a smart grid is described as a network which uses information technology to deliver electricity efficiently, reliably and securely. So it is also known as the electricity of the brain or electronet. Smart grid is defined like that. And based on the National Institute of Standards and Technology, NIST USA, they define smart grid as a modernized grid that enables bidirectional flow of energy and uses two-way communication. So in one line, smart grid is just a network which uses a bidirectional flow of information and energy that will make the grid smart. So from a layman's perspective, we all are familiar with the UPI banking. We all having some UPI banking devices, applications in our phone, just like Google Pay and all, where we are able to know the account balance, transfer money from one person to another, to his phone number, based on his phone number or the account and all, or to another QR code in a shop and all. So we may not have the bank's app in our phone. Like we may not, if we are using SBI bank, we may not be having the SBI's mobile internet banking app in our phone, but we'll be having the Google Pay or the other UPI app. Why we prefer such app is that we can manage the whole bank account using that single app. That is why we prefer that. So using the smart grid, the customer can be able to manage his consumption completely through smart meters and all. He can regulate his consumption, he can adjust his consumption, etc. One such application is the Amazon Alexa, which most of us are familiar with. We can tell the Amazon Alexa that Alexa, you have to schedule the washing machine to operate at this point of time, or any other load to operate at this point of time, which is away from the peak load time, so that we can in some part of the country as well as in outside countries also. There are some, if you are using electricity away from the peak load time, there will be some incentives or the tariff will be less, comparatively less. So we can inculcate this artificial intelligence into the grid to make the grid smart. Here is where this big data analytics comes into the picture. So we are having a lot of wind, solar energy, etc. and all, which will store the generated electricity or power, or it will get transmitted. And these are actually connected to the energy management system, which is the EMS, which is the center part. And we all are familiar with this electrical vehicle and all. Some of you may be working on this area, or some of you may be planning to purchase one soon, waiting for some good brands to come out in the future. They can be connected to the charging points also. So there also we can use this communication part for charging them, which can be, we can fix the period at which they can be charged or not. So coming to the conventional and smart grid comparison, the first point is devices. In comparing the devices, all the switches, circuit breakers, etc. in the conventional grid are electromechanical in nature, whereas the smart grid, these devices are actually digital in nature. So that does not need much description at all. So we are familiar with that. And the communication also, we just discussed it as one way in case of a conventional grid, whereas it is two-way in case of a smart grid. And this generation is also discussed. We are having centralized generation in case of a conventional grid, where the consumers only consume, generators only generate. But in case of a smart grid, the consumers can consume as well as they can generate if they are having that facility. And the next point is the tendency to being prone to faults and blackouts is more in case of a conventional grid compared to that of a smart grid. And we know that though the smart grid is more advanced, it is actually a bit complex. Like we are making it a bit more complex by adding sensors everywhere, etc. So we'll get a dynamic picture of the smart grid. So the sensors are more in case of a smart grid, and the restoration is self in case of a restoration healing. They are self in case of a smart grid. So it can isolate the faulty location and remaining part can be connected without any human intervention in case of a smart grid. Whereas in case of a conventional grid and all, we require human intervention to manually connect the grid which has been isolated. So this figure, it shows the interoperability of various sections in the smart grid. We have the generation here. The generation, the transmission, the distribution, which are the main three parts of the power system. Then we have the customers, the operations and market control and the foundational support system where the control decisions are taken. All these are interconnected actually. That is what the peculiarity of a smart grid is. So based on all the data which is flowing from different parts of the smart grid, the decision is made accordingly. So this is the major challenge also in the smart grid, to make a decision based on the big data analytics we receive. So one of the major devices which is used for monitoring or for collecting the data is PMU. So I'll be giving more stress on the PMU because I think for the previous sections and all, we have seen much other sensors related data, content and all. So I'll be concentrating a little bit on PMU. Then we'll move on to the big data analytics part. Okay. So this is PMU, a block diagram of the PMU. It is known as the Phasor Measurement Unit. So it is a measurement system which is used for measuring the, we'll get the output of magnitude, phase, the frequency, and the rate of change of frequency of a bus voltage in real time. This is actually in a three-phase way. We will get the three-phase magnitude, voltage of current and voltage as well, frequency and rate of change of frequency. Okay. So each phasor measurement recorded by the PMU device is actually time-stamped. So in case of a conventional grid, we used to get data from different parts of the grid, but we don't know at what time the data was measured. So it is difficult to structure it in such a way that we cannot get some proper results while processing, or it has to be locally processed. It cannot be centrally processed. So in case of a PMU, the advantage is that since it is timestamp, we know that at what time the data was collected. We can actually, while collecting, we can actually structure it in such a way that we can organize it properly and process it. So the difference in voltage amplitude, we can address the reactive power issue by measuring the difference in the voltage amplitude, and based on the frequency and all, we can address the difference in the active power flow and all. So the system operators utilize the synchrophasor or the synchronized phasor measurement to monitor this power flow and all, and based on that algorithms which they use for this data processing, it can we can get good results for the fault, to identify the fault location or any sort of events, or even we can use it for state estimation, which I'll be discussing, and another use will be in oscillation monitoring. All this, most of the points are discussed actually before. So basically there are three components which are shown here. One is the measurement part, which is having the anti-aliasing filter. So the analog inputs which are in the bus, we connect it to the anti-aliasing filter, which forms the measurement stage first. And the computation part is the second part, where the it has a ADC, this analog digital converter, and a GPS receiver, and a phasor computation or phasor processor. So here the computation of the phasor takes place, and the GPS clock, it will timestamp the phasor. And in the communication interface, the data is streamed to the digital network, and the IEEE P37.118 format is used for streaming the data to the particular device. So next the hierarchical order of the PMU, the next stage is the PDC. The PDC is a phasor data concentrator. It works as a node in the communication network, where we can see that different PMUs are actually, we are communicating their data to the PDC. So it is actually a node in the communication network where the PMU data from different PMUs are processed, and actually it is fed out as a single stream to the higher PDC. So PDC itself, we are having different levels of PDC, substation level PDC, higher level PDC, and super PDC and all, which are having different applications and all. So one point to note is that the PDC does not store any sort of data. It just collects the data and it actually sends it to some processing devices and all. It does not collect the data or store the data. Okay. So the challenges in big data analytics are the same as the advantages of the smart grid, which we saw before. So we first on the advantage or the definition of the smart grid, that it helps us to monitor the grid, then it gives protection and it gives a wide control over the grid. So these itself are the challenges in big data analytics, because we have to overcome these challenges in order to make the grid smart. Okay, so the next point is the 5 V's of big data. I'm not pressing much into it because the previous session, ma'am already had addressed all these things in a very good manner. So I'm not addressing much into this one. So I'll be going into a big data analytic problem, which was published in IEEE Transaction Smart Grid paper. Actually, it is an interesting problem. We have seen different types of quality level problems and all addressed by eminent speakers in this session. So I thought of providing an interesting problem. So this is the data analytics based on a risk formulation of tree trimming. Actually, I'll show the diagram for that first. Okay. So this is actually a problem where the tree is close to a transmission tower, or the transmission line, that the pole. So in the first figure, this figure, we can see that there is a 15-inch difference between the transmission line and the tree. Whereas based on the growth and the timeline, we can see that the distance reduces from 15 to 13 to 7 to 6, to 0, where it touches the where it touches the transmission line, and it causes some fault. So we have to know that this monitoring level, big data and all are in a wide, it comes in a wide aspect or wide range, from wide ranges of sensors. So here the sensor is actually monitoring the distance between the tree and the, or it may not be one tree, actually it may be some huge range of vegetation where the transmission line is passing through a forest area or something. So the dynamic trimming of the trees has to be scheduled, taking into consideration the growth, the weather aspects, the environmental aspects and all. So all these things all data has to be compiled and processed effectively, so that it will effectively, dynamically, we can trim the tree so that there won't be any fault occurring in the system. So I will be giving the reference in the references. You can go through the reference in detail. So here a risk formulation is proposed in this paper, Rx of T, where it takes into consideration the hazard, the vulnerability, and the economic impact, the cost of period of and the reactive tree trimming and all. So it takes all these things into consideration, where the sub reasons of the causes, sub reasons of the causes are also given. So it takes all these causes into consideration and formulates the risk factor, and it optimizes the decision when to trim the tree and all, so that we can get an effective output of the data which we collect from the sensors. So this is the problem which we face in any big data application. We have a lot of data, but we have to process it so that we get a suitable output. Okay, coming into the PMU based dynamic state estimation. So those of you who are working in this area, they know that some of you may actually simulate a PMU in MATLAB or some software, but they know that sufficient samples of PMU data are required for research and designing of some wide area monitoring tools in power systems and all. So some of you might have contacted some power utilities and all to obtain this real-time PMU data, or PMU data which has been actually collected from some devices or monitoring measurement. So we know that obtaining this PMU data from utilities and all for testing and validating our algorithms or the processing programs and all is a it is a cumbersome process, because of the privacy and security norms set up by these utilities. which own and operate the PMUs, because they won't be able to provide us with the entire data and all. But they may be giving some sort of data, but it may not be fully useful to us as well. So that is a problem with this thing, this PMU based, one of the drawbacks of PMU based state estimation. So the state of the system is actually, it is actually the static state vector is sorry, there was a power failure. Okay.
I know there is a power failure in the campus. That's it.
Okay, am I audible now? Am I audible?
Yes.
Okay, thank you. Okay, so we were discussing the static state vector. It consists of the magnitude of voltage and phase angle. So monitoring the state of the system on a static basis is not actually a very, what is on a static basis not what we require. We need to monitor it on a dynamic basis. So we have to convert, we have to upgrade ourselves from this static state estimation to dynamic state estimation. So in static state estimation, the vector comprising the magnitude of bus voltage and phase angle is known as the state vector, static state vector. So similarly, a power system's dynamic state vector includes the generator rotor angles. It includes the generator rotor angles, the generator omega, and based on the model which we are using the generator, we will have other parameters as well. So the dynamic state estimation actually gives the better picture of the power system dynamics. So this will help us in monitoring the power system as well as initiate appropriate protection and control strategies, which will help in improved oscillation monitoring, etc., or the other security assessment schemes and all. So there are a lot of techniques which are available for this and all. So the basic reason for estimating or state estimating is that we cannot place a PMU in all the buses. So if we are having say 100 buses, we will have some criteria, some observability criteria for placing the PMUs and all. So based on that, actually, it's actually an entirely vast topic, that PMU placement, optimal placement topic and all. So it is another topic which requires specific research interest and all. So if we are having say 100 buses, we will not place the PMU, or we cannot. Economic constraints are there, so we will not be able to place the PMUs in all the 100 buses. So we will be limiting the number of PMUs to certain buses. So that is, there occurs the problem of state estimation, because if because we do not place the PMUs on all buses, we will not know the all the parameters in all the buses, because in those buses which we place the PMUs, we get the data from those buses. Other buses we have to estimate the data. There is where this state estimation comes into picture. So we have to estimate the data so that we will not we will be accurate as well, and we will not lose any sort of information. So these techniques which are used include the weighted least square method, which is a primitive method, and the newer methods include the Kalman filter, the extended Kalman filter, the unscented Kalman filter, and some modified versions of extended Kalman filter and the unscented Kalman filter. Some of the topics, some of the methods are techniques used are so on. So another problem which we face is that the PMU, with the PMU, or it can be a challenge of the PMU-based estimation techniques is the missing data. Is the missing data as well as the noise in the measurement. So the missing data is nothing but there are other points as well, which include bad data as well. There are many challenges are endless. Okay, I'll be discussing these three in detail because this has not been addressed much. Okay, missing data is nothing but when a PME or a communication channel has failed or undergone any failure and all, we will not get the PM data from the particular PMU. So the state estimation, that technique, they will the algorithm will think that a fault has happened and it will take control strategies accordingly. So actually the PMU is working fine. Maybe there is a problem in the communication channel, but the data is not actually communicated through the channel to the hierarchy level, say PDC or the algorithm where our application for estimating the state is available. So since it does not receive the data, it thinks that a fault has occurred. The line line is open. That is why it is not getting any data. It may think like that. I mean, it may calculate like that or estimate like that. So such issues we have to address. Another issue is noise. Noise can occur from the measurement side as well as the communication side. So this noise can actually interfere with the data and cause errors in the state estimation as well. A similar problem is bad data, where bad data can be of different types. So we'll be discussing, as I told, we'll be discussing about the cyber aspects of the bad data. So bad data can come as a result of the measurement problem or the device problem, as well as some cyber intruders or hackers can also they can intrude and make the data bad or make the data not worthy of getting estimated or getting a proper output from the state estimator. So these are some of the challenges which occur when we perform state estimation using this PMU data and all. So that is why we often go for this artificial intelligence or machine learning techniques, so that we can overcome even if this bad data or data is missing. And if there is, suppose if a line is open, a line will be attached between two buses or 2 points. So if there is not much significant problems in the other nodes and all, so the machine learning algorithm or the artificial intelligence technique can be trained in such a way that if there is no particular difference in the values between these two lines before when the data was missing and after the data was missing, it can consider that it has a missing data problem, and the algorithm can function as such without giving importance to that problem. So this is where we use big data frameworks and all. So the core features of selecting big data frameworks is listed here. The first one is the programming model. The second one is the programming language, and the data source type, the type of data source which we are relying on. Then the integration of framework with existing machine learning libraries and the fault tolerance approach. So it will be different for each and different application. So whatever application it is, it will be having certain platforms which we have to use. And I have listed a few platforms here. First one is for data generation. We'll be discussing it in the smart grid point of view. So we know that the smart grid monitoring data is produced from a different range of smart meters. Just we told some we discussed some like PMUs and all. Also, it is generated from electric vehicles, private houses, offices, then industries, solar farms, etc. and all. So this data can actually, it can belong to the generation side, transmission side, or the distribution or the consumer side as well. As well as we have seen in the previous example about the tree trimming, dynamic tree trimming conditions. So many weather data, meteorological data, etc. can also be taken into consideration. So these all data generation is taken from the advanced metering infrastructure, sensors, SCADA, PMU, etc. So the next stage which occurs in the big data framework is the data acquisition stage. So actually this data acquisition stage can be subdivided into 3 stages, further 3 stages. So it can be the data extraction, and the data pre-processing. Okay, so we have the sensors and the measurement devices. So they actually proactively gather data from different points in the smart grid. And this data is actually sent to a cluster node or something. And here I have introduced, I have mentioned the platform which is Flume, and it is a platform which is developed by Apache. Okay, so the obtained data is sent to this master node or the cluster node, and the data is processed here, and it is transmitted to a data storage system for analysis purpose. So the data may be a complex set of data, so it will have different formats and details. So that will have with that necessitates the stage of pre-processing it. And in pre-processing is where we actually, I told some issues regarding the PMU-based state estimation without using this machine learning and AI techniques, that we'll be having some missing data, all these things and all. So in pre-processing stage, we'll omit or we'll reform this incorrect and missing data to enhance the data accuracy. So that is the second stage in the big data framework. So the third stage comes with the data storage and processing side. So here we are having some common techniques. Basically, this HDFC is the Hadoop-based distributed file system. So what it does is that instead of focusing on costly or economically high software and or dedicated software, it allows parallel storage of massive volumes of data, basically on some standardized servers and all. So that is facilitated using this HDFS and all. And this HDFS, it actually it is designed to operate on this Google's architecture. It operates on this Google file systems architecture. And some other platforms include this MapReduce, Yarn, Cloudera, and Hortonworks. Okay, the next stage is the data querying, and I'll combine these stages and discuss the data querying and the analytics stage. So the method smart grid data must be transmitted dynamically or instantly to increase the smart grid performance. So that instantly if we process it, because the power system transients and all, they are very, they move, change very dynamically. We have to act very soon, otherwise the fault will cause some blackout or some heavy failure, which will be economically destructive as well. So we have to transmit the data on a real-time basis dynamically, so that we can increase the smart grid performance. So the data which we the data which we process actually that comes in this stage, which we are using platforms like this Impala, Hive, Apache Pig, Tableau, and Mahout, and SMAO. The operational decision making actually it involves a sequence of analytic processing. Example, if you are having a given range of power system faults or events, to make an optimized decision, and monitoring, we have to make an optimized decision, monitor the consequence of the fault, and consider the impact assessment of the action taken. And based on that, actually, we have to tune the system again. Actually, different faults may occur, and we have to tune the system actually, because sometimes our system, what Prapti ma'am was telling before was that we make, we researchers actually, we do simulations or make some models, and it may not be applicable for the real-time power system, because one problem is that we are not actually getting the real-time power system data, because if we are modeling a generator or a power system, we are actually making the ideal, we are doing the ideal model of the power system, but a real-time model or the practical model of the power system will be entirely different from that. So what we have to do is that unless we train the power system with real-time data or real-time using real-time model of the power system, our model will not be useful for the real-time power system data. So that is what the issue which comes in the data analytics stage as well. So that is the stage which we have to use adaptive analytics, so that based on the situation, we have to adapt the algorithm or the analytics so that we'll get the desired output or the output which we are expecting. So this is a smart grid analytics stage. We have to assess the risk, then take needy decision, then we have to assess the outcome. So just by giving an algorithm training with some data is not sufficient. We have to assess the outcome, whether the algorithm is working perfectly under an event or fault which we have trained for, and we have to validate the model. And then based on the validation, we have to improve the model. And then we have to again implement it here. And this stage is actually a repetitive stage. Just like we all are not a perfect, even if we are doing some research or any activity, we are all not perfect. We are learning, in each stage we are learning something. So similarly, this data analytic algorithm also, we have to adapt it in such a way that it will learn continuously and it will yield a better result every time. So I'll be giving a overview of the machine learning and artificial intelligence approach to big data analytics. So we know that there's significant developments in this monitoring area, that is the sensor technology. Then we are having automatic meter, etc., the PMUs and all. So this has actually improved the quantity of data, quantity as well as the variety and velocity, as well as the 5 V's actually in the distribution transmission networks as well. So we are having the data acquisition stage here. Then we pre-process it, then saving and processing the training, and we use it for the real-time monitoring stage, and here we get the output. The output is for which we are actually working on. It will be actually based on the algorithm which we develop. It can be like previously I told, it can be for event detection, the oscillation monitoring, the state estimation, etc. So all these comes under the output of the based on the big data which we collect and we properly analyze it. So the communication stage is actually, it comes in between many times. So what we generally use internet to communicate things. There is which we use the term IoT, which has been discussed many times in the FTP as well. I will not be giving a very descriptive lecture on that. I'll just go briefly with that, and I'll move on to the cyber attacks in the power system. So the Internet of Things, it actually refers to a system of objects which are interrelated. It is actually interrelated as well as connected to the internet, and they are able to collect and transfer data over a wireless network without any human intervention or human help. So the problem basically which we face in the cyber area is that because of this integration of IoT in the smart grid, it develops a dynamic interconnected network, but a vast amount of data is actually processed in the cloud, and it is sent actually through the communication. Mostly it is sent to some open channel and all. So the violation of data privacy is actually a serious concern. So this dynamic network this causes a security threat, and it is actually quite serious because it is vulnerable from when both the demand and supply terminals of the power grid are affected. So some hackers and all, if they intrude and if they pollute the data with some, or manipulate the data with, it will cause the estimation algorithm or the AI or ML algorithm, they can treat it as a fault and take the action accordingly. So such cyber attacks actually must be prevented actually. So basically, this was one of the doubts which I was having. I had asked to one of the speakers yesterday that whether like missing data, which I discussed before, missing data can actually come from a PMU failure or as well as a cyber attack threat. So how do we identify whether is there any steps in identifying whether data is missing due to a PMU failure or a cyber attack? That is actually a question which I have been searching for the answer for little while. So what the answer I got was we are having a specific a layered solution is needed so that we can identify a layered solution is needed so that we can identify the difference between the threats which occur due to the cyber side as well as the other side. So if it is the cyber side means there is no point in checking whether the PMU is malfunctioning or not, or whether maintaining or giving prior importance to maintenance and all. So we can improve the cyber security as well. If there's a layered solution, we can identify that particular problem is coming due to the flaw in cyber security and all. Now we'll move into the state and scope of some cyber security threats and all. So the SCADA systems actually did not have any sort of problems before because they were actually sending data through some communication channel, hardware communication channels and all. So the main challenge when the smart grid or the PMU was introduced is that the IoT modules were connected across the local networks and all, and that actually it exposed to multiple loopholes and cyber attacks. So one of the prominent teams which analyze this is the ICS-CERT, that is the Industrial Control Systems Cyber Response Team. So they analyzed that in 2014, the report which they gave in 2014, they analyzed that 79 out of the 245 critical infrastructure events that were reported were aimed at the power sector using the cyber security flaws. So depending on this motivation and reasons of attacks, the risk can be classified as these four types: the internal malicious attacks. That is actually the attack due to the operator, workers, or consultants. They knowingly they cause hazards. So if you're working as if you're working as an employee in some power organization, and if you are not satisfied with the management's response to you, I mean, you can, when you decide to cause some damage to the company, you violate some terms and conditions of that company, you share some data which has to be private. Those sort of activities will lead to some internal malicious attacks. So internal non-malicious attacks involve an example is that when an operator makes an unintended error, then harms the power plant assets. So if they are, instead of carefully doing something, if the operator actually is careless as well, then it can harm the power plant assets of that organization. That comes under the internal non-malicious attacks. So the external opportunities attacks and the external deliberate attacks are mainly these are the attacks which are conducted by the hackers as well as the groups which are aiming at some weakness of other countries or other states' power system. So in external opportunities attacks, the hackers, they challenge or they mess around. Like we have seen some viruses in previous years, like they attack the computer system just to gain some publicity of their firm or their organization. So and so, some of them even don't demand any money. Some of them demand money, but some to gain publicity and all, they do that. That comes under the external opportunities attack. And the deliberate attacks is that some group is exploiting the weakness of a country or a state's power system, so that it will affect the process. I mean, it will affect the economy of the whole country as well. Okay, so some of the solutions or the detection techniques are underlined below, and their references are also given. And in the last 30 years, actually, this machine learning is not actually a very new topic. It is actually a topic which has been emerging from the last 20, 30 years, actually. It has proven highly effective in this process analysis. And one of the basic, one of the detection techniques is the SVM, or the support vector machine technique. And in this paper, actually, they test this SVM method in a Microsoft malware protection, and the outcomes are very much effective compared to the other approaches which use SVM. They detect this malware very effectively. However, the absence of any adequate internet technology, IoT applications and all, will create the effect if there are no adequate IoT applications to secure the private and sensitive transmission of data, then it will lead to cybersecurity threats. Some other techniques involve the blockchain technology in this reference, as well as the Kalman filter for FDI. I'll explain it now. Okay, we have seen the types of attacks, but in this opportunities or deliberate attacks, they can be further classified into FDI, then comes jamming, and the third would be access denial. So there are there are more types of attacks. These are the main three classifications. And in FDI, the full form is actually a false data injection, FDI. The threats actually, they introduce deceptive or false data to the sensor measurement, just like this bad data. And in jamming, what they do is that the attacker, they corrupt the meter measurements by some other values to the measurement. And in this access denial threat, what hackers do is that they obstruct the device access to the meter measurement. So the device which is actually accessing the meter, they are not able to access due to the access denial. So this reference, 9 and 10 references, they provide a very good technique using Kalman filter to detect the FDI attack, the false data injection attack threat. So what they do is that they primarily quantify a particular parameter disparity, that is a change among the actual meter measurement as well as the expected reading. So they will compare this actual meter measurement and the expected reading. And if an abnormality or a disparity reaches a specific threshold level, it reports an attack. And these detectors actually, they don't recognize that the relationship between attacked or anomalous observation, and they create sample by sample. We have to create sample by sample judgment for that. So that is a good technique which they have followed. And another two techniques are the one used by least square, using least square technique and the Markov graph framework as well. So one of the recently, yesterday, when I didn't add it into the slide. Yesterday, when I was going through one of the slide preparations, I found that the World Bank estimates that in India, the GDP of India is actually, it reduces by 1.5% due to this power theft. This power theft is also actually, it can be classified as one of the cybersecurity problems, because if it is not, if the hackers actually create some data in such a way that the theft in power cannot be identified, it can also be, classified as an issue of cybersecurity issue also. Because if the data is manipulated such a way that there is no consumption, or the voltage and current monitoring data is manipulated, then the meter readings also will be manipulated, obviously. So that is also a valid point in this discussion. So we can conclude the discussions which we have gone so far. Like the upgradation of the, we have discussed the upgradation of the conventional grid to the smart grid, and the big data analytics have evolved for sensing, handling, and controlling of big data emerging from the smart grid. And we have to adapt to the challenges of big data. They change big data analytics. Based on the scenario, we have to adapt the techniques so that it incorporates the challenges in a real-time basis. And we have discussed a little bit in detail of a technique, analytic techniques where a risk formulation technique was formed for a dynamic tree trimming purpose. And we also discussed the PMU-based dynamic state estimation and the cybersecurity aspect of the smart grid. So as I told before, if anyone is working in this area or interested in this area, and if they are willing for interested in a deeper discussion, which is beyond the discussion in this portal, they can email me. And if there is any scope of collaboration in work, if you are doing a research, then we can discuss about that also.
Participants, if you have any queries, you can ask now.
Yeah, I have got some queries.
There is one query in the chat box. Yes, sir.
Yeah, I can see it. Okay, what is the number of samples per second from PMU? Can you compare that from SCADA other than time stamping? Okay, the number of samples per second in a PMU, actually they vary based on the frequency. Like in India, we follow 50 hertz frequency, and in certain other countries, they follow 60 hertz frequency. So it is actually in India, I mean, based on our requirement and the application which we are using, the samples can be adjusted actually. So it up to what is the latest, according to the latest information I have gone through, up to 230 samples per second a PMU can, at a second it can actually collect up to 230 samples. So based on the application, we can adjust the samples. Like if we are monitoring a system, power system in such a way that there is no, it is a prominent, if it is prominent to fault, means you can actually increase the sampling rate. Whereas if it is not prominent, we can decrease the sample rate. So because this high sampling rate can lead to high quantity of data, which is again a stressful activity for the big data analytics part or the processor part. So one of the smart meter technique which uses the highest sampling frequency is the automatic fault recorder, that device. It is an automatic fault recorder or the dynamic fault recorder, I think, DFR, I think. So it uses the highest sampling rate, and it only samples during the fault. When a fault is detected, only it starts sampling. Otherwise, it does not sample any data or collect any data measurement. So in comparison with SCADA, actually it samples in once in maybe in a minute or two, like that. It differs from different equipments manufactured by different manufacturers and all.
Shall I read the next question?
Yeah, one more question I have got. Are the platforms mentioned for big data framework open source? Yeah, actually, many platforms are open source. The Hadoop-based platforms and the platform often offered by Python and all. Python is is an open source platform which you can use for almost all machine learning techniques and all. So it is easy to program as well. Even if you are not having some system requirements, like if you are running Python on a 4 GB RAM operating system or a laptop or a PC, you can the Python is collaborated with Google Colabs, which offers I think around 256 GB of RAM. So you can program actually on a Google Colabs platform where actually you are using the Google Colabs RAM so that you can run high processing applications which require a high RAM content and all, can run on their platform, and you can use the benefit of their platform. So one more question I have got. how can we decide which method is to be used for analysis? Detection technique. Yeah, this actually it is based on the data as well. So I mean, a biomedical application cannot won't be having the same application as an engineering, I mean, power system application. So that is actually we have to since we in a research point of view actually we cannot actually we won't get the time actually to find out by trial and error method. We have to rely on this previous researches based on that. One typical example I would tell is based on the wavelet transform, which is used for decomposing the signal and all. So that the wavelet based event detection methods are very common, and it is actually reported from 5 to 10 years before itself. So in that, actually, what we do is that we decompose the wavelet into into different frequencies, and we take the predominant levels. Actually, if we are having a signal, we decompose it into certain levels, and instead of and the signal, suppose the signal is having a disturbance at say at the 5th second, and in the signal we cannot be able to differentiate the disturbance. So the signal is that much having some noise or some other disturbance, but if a prominent fault or a disturbance occurs at the 5th second, and we use a technique such as a wavelet transform, we can decompose the signal into certain number of levels, and the prominent disturbance will come in one level. But the main issue is that each application will have, we have to use different levels. Different level or the type of wavelet transform will vary accordingly. So that we have to do some study before that. Actually, we cannot, particularly, we cannot tell that so and so application can use so and so. That is not a proper answer which I can give. So based on the researches, only we can, can come to a point that we can rely on this method very well. And otherwise, we have to try it on our own, and we can compare using different techniques used. Yeah, which platform you use for the coding part? Yeah, coding part, I suggest this Python is very much, I have told the advantages of Python. That is very much which we can use for the coding part. Another question is that both SCADA and PLC can be used in collaboration with IED and PMU. Yeah, that is also possible, and that is also being done, because in smart grid we already discussed the 5 V's of smart grid, and we have different. In one is the veracity, velocity, variety, and in variety means we are having different data. Even SCADA is running. I mean, we are using SCADA now as well, but since until we replace all these SCADA with PMU and this PLC with IED and all, so we have to continue using the data which we receive from these devices. So until then, we have to adjust our processing techniques to integrate these type of data from these measurements. Optimal placement of PMU in power network, additional cost in system because of PMU. Yeah, optimal placement of PMU I have not considered in my research work. It is actually a very vast topic, and there are many criteria which use many criteria proposed by many researchers which use different methods for placement of PMUs. So it is actually a different topic. I have not considered it in my work. It is actually a very vast topic between. So it is you can consider that also if you are doing some research on that. You can consider that also. Okay, another question is that for power system data analytics, any data available publicly? As far as the research which I have conducted, I have not found any data publicly. Yesterday, when I came to know, I think some New England Open PDC, some faculty have delivered the lecture, they answered some question in that way. Apart from that, from Indian data, I have not obtained any data in a public platform. We have got some data from POSOCO, the PMU data. What we did is that we mailed from our college department head to requesting them to send some data regarding the PMU data from which includes some faults or events. But again, the problem is that the data are limited which we get, and which it may not be sufficient to process, run our algorithm. So what I suggest is that you build up your own PMU, develop your own PMU, and try to find what all disturbances are occurring in the power system, such as noise and all. You try to simulate them, and you create your own PMU data. And based on the PMU data, you try to validate your algorithm rather than waiting for the PMU data. So once you get the sufficient data, you can adapt your algorithm accordingly, so that your algorithm will work with the real-time PMU data as well. Additional cost of PMU, I don't know actually the exact cost of a PMU, but comparatively, in distribution side we use micro PMUs, which are much less costlier. Maybe the PMUs cost at least 1 lakh or above, in that range, which the PMU which I have seen in CPRI Bangalore, they told that the estimated cost is around 3 lakhs for that. So the much less costlier equipment is the micro PMU, which do the same functionality as the PMU, but they are less costly also. Smart meter response is not great in many areas across India. What are the remedies to improve it? Smart meter, can you be more specific, like whether it is the problem due to the smart meter or the analytics part? Smart meter response is not great in many areas across India. What are the remedies to improve it? Okay, I think I have finished except this one. I finished with all the other questions. Any other question which have gone directly to the panelist, please let me know.
Yeah, there is one question. What is the difference between the island mode and captive power plant in smart grid? Shall I
Okay,
repeat the
what is it?
question?
Yeah, on here actually.
What is the difference between the island mode and captive power plant in smart grid?
Okay, island mode is actually in a smart grid actually. More specifically, if we consider it as a microgrid or some different sections or parts, when we are having a fault in some part of the system, we island it, like completely detach it from the remaining of the power system or the grids. Whereas in a captive power plant it is actually having the user is having a localized source of power. It is not actually connected with any other part of the grid. Typical, we can example is that so they have their own source of power, as well as they operate also in synchronism with the grid. Sometimes, if they are not able to satisfy the power, they actually take in power from the grid, or since they are generating, if they are having excess of power, they give it to the grid as well. So it is actually a captive power plant. You can actually compare it to a independent independent area of the grid. Independent network which has their own generation as well as load. Yeah, thanks, Sharad.
Participants, if you
Yeah, even if you have any queries after going through the presentation, all the presentations will be available in online. You can, just leave a mail to me. I'll be happy to reply to you.
yeah, okay. On behalf of Power and Energy Group, NIT Calicut, express our sincere gratitude to Mr. Subin Koshy for accepting our invitation to be a part of this online ATAL FDP program on application of artificial intelligence in power system operation and control, and giving some thought-provoking ideas in the area of.
Thank you, Ms. Subin. So tomorrow session will start by 9:30. So the link and schedule will be circulated to you or shared with you today evening itself. Okay. So thank you, Mr. Subin.
Yeah, thank you. Welcome.
Yeah, thank you. Welcome.
Tomorrow session starts by 9:30 by Satyajit Das, Dr. Satyajit Das from IIT Palakkad. Then after that, Dr. Shabuddin from NIT Calicut. Then there is a MATLAB session from 2 p.m. to 4 p.m. Okay. So please make sure that you have already I have informed you in the communication. I have started in the first approval letter or even the first acceptance letter. So you need to have MATLAB, at least the latest some 2018 or higher version. Okay. So you can use the online MATLAB if you don't have. You can try with the Scilab or Octave, but I think this is basically they are explaining you or giving you an idea about the applications of MI and AI tool on MathWorks. Okay. Thank you all.